こんにちは。QC ウェアで代表事務。
Hello, my name is Bill, president of Q2B Japan. So today in my presentation, I would like to talk about potential content disruption and how we are supporting for that upcoming disruption. And so first I'd like to introduce what we do at QC and it's a venture company. And Palo Alto is where our headquarters is based in Paris, France. We have an office there too. And in April, we have just opened a Japanese office. And Nishishimachi area of is where we have Japan office. And we have $25 million on Series A. It's in Japanese yen about 3 billion yen. So we have got funded it. And lead investors is Koku, the technology and EcoBest are the main investors. We have 60 employees working with us. Three-quarters of them are engineers.
QC ウェアを
So what we do at QC Ware, simply put, it looks like this. There are three things that we are engaged with. So first one is about preparing. We are providing specialized services so you can better prepare for quantum computing. We also develop algorithm software. Third one is about community, building community. And we are a software company. Software and algorithm is the angle in which we are putting applications together. So hardware manufacturers are developing, and when they are launching a new hardware product to the marketplace, so hardware with more qubits and with better qubits are being developed by them. In our context, when we put new algorithm, so if there's a same set of question, we want to use fewer qubits and with better performance. So in between that, that's where quantum application that are practical becomes available. So we do have a mission at our company. Be the first vendor to offer practical advantage with quantum computers. Very first vendor. That's our mission.
QC ウェアは
At QC Ware, and our engineers, quantum algorithm, quantum hardware improvements are the focuses that our engineers are prioritizing on. These are the application areas that the teams are focusing on under chemical simulation and also optimization. For optimization, include logistics, manufacturing. We also have machine learning, and also image recognitions, Monte Carlo methods for risk assessment for financial services. So when they become, practical available, it's up for discussions. But the most quick ones is a chemical simulation, in our belief, that will become practical earlier than others. We are having many different collaborations in publishing papers. This is a list for last year, 2021, the list of papers. And this is the list for 2022.
すべての論文
All reports and papers are available from our website where you can access them. And they were categorized, into different topics. So please come visit us. And next, I'd like to talk about collaborations.
今まで
So far we have more than 45 commercial contracts being signed with the more than 25 enterprises customers are working with us. So first on manufacturing area. So the use cases include software quality assurance and also design verifications. Icing Group is the customer. You know who they are. Automatic transmission manufacturer, they are. And also Airbus from Europe. And the goal for this collaboration is having a high performance computing was the goal of that project. And we do have collaboration on supply chain optimization. Now the customer again is Icing Group. Our goal for that was on-time delivery and reduction in miles driven.
Scheduling.
And we do have a use case around scheduling. Our partner was NEC and BMW. And the goal for that project was to increase production throughput. Yes, increasing the throughputs. And at the bottom of this slide, you see the quality assessment, which the partnership was with BMW, and the goal for that project was better identification of manufacturing faults. And next example is about life sciences, and the collaboration partner was Roche. It's a pharma company based in Switzerland. The use case was the biomedical image analysis. And the goal for that project was more accurate medical diagnostics and personalized treatments. And next example, sorry about that, is a collaboration with Birmingham, England. It's a pharma company in Germany, the world's largest private pharma company in the world. And the use case was production of drug bindings to proteins. And the goal for that project is shorten time to explore and field new pharmaceuticals. And next example is material design sector. And Covestro is a partner for that. Like I said, they are one of our investors. And with Covestro, they are the manufacturer for polyurethane product. And under this project, so the goal was a faster path from R&D to the market, as well as enabling recycling features. We just have a 5-year collaboration contract just been signed with Covestro just the other day, and with top 5 auto OEM. We are doing a collaboration project with battery design. The goal for the project is to improve driving range and with the reducing charging time so that we can achieve better sustainability. Next example is with the financial services. Collaboration partner for this one was Goldman Sachs. And the use case was about derivative pricing. And it takes today one full night, and you'll be able to do that with the overnight. And Itaú, which is a big bank, the use case for that project was customer retention. And the goal for that project was avoiding losing high-value customers to competitors. So that was the objective of that project. At the bottom, we cannot disclose the name, but this is one of the investment banks. And use case was trading and hedging, and the objective is the same. So avoid losing high-value customers to competitors. And energy example, BP oil company was the partner for that. With the power tolling, power trading was the use case. And efficiency and fair energy trades was the objective for the project. And at the bottom, you see an example from energy company in France, Total. And the use case with them was crude blending with the goal of lower losses and reduce carbon footprint. And next section is about professional services that we do. And so there were 3 levels of services that we provide to a customer. The simplest one is like workshop, where maybe you don't know anything about quantum computing. If your business don't have any experience around that, we can have a 2 days workshop. And you can learn about hardware and software. You can review them and decide what use cases to focusing on. Next step is standard project. Standard project usually takes several months. But the objective of that project is to decide what to focus on proof of concept.
3番目
And the third is advanced project. This is how the workflow looks like in advanced project. So the difference from the standard project is, in case of a standard project, we'll use available algorithm that exists already. Now, in the standard project, we'll identify a use case, and that use case would be processed with we'll do the mapping so that the quantum algorithm will be able to use that. And the next step starts where the research process starts. At that stage, we will define new algorithm for that. We'll build that under this project. Our team members and the collaboration partners teams will closely collaborate to develop completely new algorithm, use different hardwares and simulators to implement. And finally, we'll make a technical report and publish papers. So under this advanced project, there are 2 objectives that we want to achieve under advanced project. One is defining a new quantum computing algorithm. And the second objective is to create new intellectual property or file for patents. And the deliverables from this project would be technical report, which can be converted into scientific paper software. And our software, so this covers like the entire stack of, we call it Forge. This is the name of the product. And QC Forge can cover all those offerings. And you can access, other partners will be able to access other hardwares, but this green, these are our special resources. These are unique proprietary algorithms developed by us, divided into 4 different categories. But binary optimization, whether linear algebra, machine learning, Monte Carlo, and yep. So these algorithms can be tried with many different hardwares, and you can actually use Forge as a package, and you'll be able to have access to all the hardware's middleware. So if you're customers, you'll be able to use those algorithms and be able to use Vanilla by D-Wave if you want that, or IonQ with Megedi hardware. You'll be able to implement that. IBMs, if you have an IBM account, and you'll be able to use IBM hardware with implementing those algorithms. Or NVIDIA's GPU might be the one that you might want to run simulation with, and you'll be able to do that if that's what you want. And this software is targeting 2 different sets of user base. So first segment is about the data scientists who may not know a lot about quantum computing, but for that data scientist, we can provide turnkey algorithm for such data scientists. So somebody, you may not be an expert on quantum computing. You'll be able to have a turnkey algorithm can be made available. We made that and be built up. And for quantum engineers, somebody who are quantum engineers, circuit building blocks are something that we provide to them. These are the building blocks that we have built with different collaboration projects, where that quantum engineers can make a new circuit of his or her own. Lastly but not least is community. This community Q2B event is one great example. So hardware vendor and software vendor under this community event can come together, as well as researchers. Building this ecosystem, we can exchange information, share different use cases, and we have built this ecosystem where people can come together. And December this year, next Q2B will be held in Silicon Valley. And I highly encourage you to join us there again. Thank you very much for your attention.